Wow, this is one of my favorite topics, when it comes to building backends. So this is one of the ways you can actually build backend in 2018, and it is way more exciting. Okay. So just before I start the tutorial and all the kind of exercises, I just want you guys let you know that this is not a beginner level course for Go or Postgres. This is sort of like an intermediate course or series where I won't be talking about the beginning aspects of Go or Postgres, but I'm going to talk about how you guys can communicate using Go to Postgres. Means how you guys can build backend where you're writing all of your model logic in Go, but actually you are pushing data to Postgres. So just mind that if you don't have enough knowledge about Go or Postgres, you guys can just research it out, see other tutorial series and everything. And if you think, or if you want me to go through that, just let me know and I'll build videos for you about Go or Postgres. No worry at all. Okay, so what is Go? Now if you guys reach here, right, then it means that you are familiar with the Go and all the advantages of the Go. So I actually don't want to tell you because you already know that, but I just want to say that it's amazing, it's modern, and it's here to stay, and it's a long time based prepared programming language which is planned really good for the long term staying in the industry. If you're learning Go, I think you're at the right place and on the right career choice you made. And other thing is Postgres. Okay, what is Postgres now? It's a database, right? It's been here like almost forever, I guess. And well, it's again one of the most used open source database when it comes to SQL in the world. It's competing with Oracle and MS SQL and all those kind of things. But one of the important thing is Postgres provides way many features that any other database in the whole world. Postgres is SQL database, but it has support for key value stores. It has support for JSON related things, BSON related things. I mean, it's amazing. They have text based searching inbuilt inside, so I think it should be really good. But in this tutorial we are not going to go that advanced. We are just going to see how we can leverage Go and Postgres to build simple models and based on that backend. So any programming language you use, right, you actually need some way to communicate with the database. Now you can actually not write your wire protocols by hand. So for that you have libraries. Some people have contributed. Well, fortunately in Go there are a lot of libraries when it comes to Postgres. Go even has official support for all the SQL databases. Still there are a few ORMs and everything which are really popular. So one of them is GoRM, which I'm not going to talk about because it's generalized ORM for Postgres, MySQL and MS SQL and all other kind of databases, right? So they are actually opting out other features, so that I actually don't like. If you want to build ORM, right, it should be perfect and it should be concentrated toward one thing. And GoPG is one of the ORM that I like to use on my day-to-day work when I use Go and Postgres because it is concentrated toward Postgres. It doesn't give a damn about MySQL or MS SQL. Why? Because, well, Postgres is being used way more than those databases. I mean, MySQL is again one of the popular choice of people when they're building where they build database backends. So this is PG, which is sort of like ORM for Golang and Postgres. It provides some added performance, so it's really good. Features, well, they have all the basic support for when it comes to the serializing packets or serializing types from Go to Postgres. So you don't need to worry about anything else. They also provide table to struct mapping. So if you can just write struct and it will get converted to table automatically, so you don't need to manage all those kind of things. And yeah, they have other support for HStore also. They have a good support for transaction prepared statements. They have a support for notification, which is kind of like unique because let's see how it pans out. Actually we'll see in the future. You will love it. That's what I think. and they have support for timeouts, and connection pooling is also there, and they have on conflict, which is like new feature that came out in Postgres for like 9.3 9.4, which is sort of like upset operation. You know, if insert fails, you can actually write another query which will run when in the case of insert fails. Yeah, so they have bulk insert update deletes, which is really good, and they have support for migration and sharding, which will also be looking into in the future. So this is like sort of like a driver, and this is how it works, and I think we should get started then, you know, without I think wasting your time. Hello guys, this is Vijay, and in this video we are going to talk about getting started with the project. You know, we'll do setup and everything. Before we do, I just want you guys to install a little bit utility called Glide. Glide is nothing but a package management for Go. If you are using Go for a long time, you might be knowing about that. So Go has by default Go get stuff, you know, but it's not that much useful when you want to do good level of project management. So I use Glide. I already had installed. If you didn't install, it's very easy. You just have to copy this and paste it on your terminal, and it should be good to go. And then you can just do Glide init on your non-Glide projects, and it will just scan it out and initialize everything. And so the configuration file is in glide.yaml. I don't think you will have to maybe ever touch that file again. Everything will be done command line, so don't worry. So it's that easy, you know. And if you whenever you want to install any dependency, you just do glide get and the path. That's it. Okay, so let's get started. So I have Glide installed already, as you can see. I'm just going to clear it out, and I'm going to create a new folder called pg tutes. I'll go to pg tutes. Okay, I'm just gonna do glide init. Okay, now as you can see, we have a glide.yaml. Just do glide.yaml. Just see nothing, right? Because it tried to scan our directory but couldn't find any, you know, Go file to scan. So that's why it did not scan anything, and it didn't put anything in the glide.yaml, but just initialization. Okay, now let's just go to here, and just instead of go get, we'll do glide get with this much. Okay, so we need this as a dependency in our project. I'll just clear it out. Okay, I'll just do glide get this path, and it's downloading now. So what this thing will going to do, Glide will going to do, it's just going to do go get, and it's going to actually store it in glide.yaml. So whenever you, for example, two guys are working, right, and you actually do some change and push it, another guy will pull it, right, and in that time, if you did any dependency, right, it'll actually, you know, it can download from there. On top of that, this is like vendor dependency. Okay, so these are not like global dependency, these are like project specific dependency. So for example, if you see the vendor folder, right, you will see github.com and then go pg. So this will locally install your dependency, so it won't affect. For example, if you're using one version of go pg in here, and if you want to update in some other project, right, then you can actually do that. So that's why it manages separate local versions of your dependency of your libraries. Okay, so this was so we actually got let's just do vim glide and check it out. Oh, sorry, vim glide.yaml. Now as you can see, it's importing, you know, this, and version is this, so it's very easy. Close it. So this is it. We actually downloaded our go pg dependency, and let's now start the server. Okay, so I have a Postgres locally installed. Okay, and other thing is, this is pgadmin, you know, for the simplicity I'm using pgadmin. And as you can see, I already have connected through pgadmin. Okay, so I have a two database right now, Postgres and tutes. So I'm just going to, okay, so this is like tutes already created a new database. Okay, so we are going to trying to connect with the tutes. So before we go that, I just want to say, just finish with the sorry, I just want to be done with the project setup. So I'm just going to open that folder now. Go to learning, and then yeah, I do so many learnings. Yeah, so this is our project. We opened it. Okay, welcome. So I'm using a VS Code because it's really good, I guess. One of the thing is it's really good, and see it's they have an inbuilt terminal and all those kind of things, so I like those. Okay, so I'm in here, and here is our glide.yaml. I'll just make the font little bit smaller, so yeah, that's it. I'm pretty sure you guys can see this. Okay, now we have a vendor and as you know, we need to create a main.go file. Okay, this is gonna be our main file. Okay, I'm using vim bindings, okay, in the VS Code, so it's gonna be like something like that. Package main, I'm just doing hello world, little bit hello world thing. Okay, port log println printf. I like to sorry, oh, it's funk. Sorry. Sorry for that, that was like some weird mistake. Going to install some dependency, I guess. It's a VS related, don't worry about that, don't focus on that. And just close this. Yeah, so this is our hello world. Let's just compile it and check it out how it works. I'll just go here, I'll open the terminal. Let's go to terminal, and it's here. I'll just gonna do go build. It built successfully. Now we have a pgtut binary. I'm just going to run pgtut hello world. Well, as you can see, so this was our project setup. Okay, so after that, from next tutorial, what we are going to do is we are going to create a separate package just for the database related things, and we are going to start putting stuff inside that database. Thank you very much, guys. I'll see you in next tutorial. Hello guys, so in this tutorial we are going to talk about how to connect with the database using a driver called GoPG. Okay, pretty simple. So the last tutorial, what we did, we created a structure, we created just a framework, we created this whole glide related you can say project. So glide is a package manager which we are going to use to install dependencies and keep track of which version of the dependency we are using and everything. Glide will take care of it. So if you see here, right, see, you can say package and version, right? So we are just using GoPG, nothing else we are using, so it just shows that. Okay, so let's get started. So what we are going to do now, we are going to create a new package called db. Why that? Well, because we want everything else that we are doing into one package. So all the database related functionality, right, you will be putting in one package. It's that simple. You don't need to worry about anything else. Just so why like this? Well, if you are a software developer, you will know that packaging your separating your code modules into packages is good. If your multiple developers are working, right, you can work on your db part, and other guy can work on the API part, and you will never be colliding your code or anything like that. So it'll be separated. Yeah, that's it. There is no actual reason. You can actually write it down, the whole db related things in the main.go, and it will work just fine, but the code won't be maintainable, so I would not suggest you to do that. Yeah, so okay, let's create a package. We created a package, we'll just call it we'll create a new file. Inside that db package, we'll call it main.go. Now you can call whatever you want. If you are you are doing Go, then you might know package DB. Let's import our driver for github.com/gopg. That's it. We can alias it using here like this. Now we are going to create a function called connect, which is going to connect to database, and we are going to test it out. It's that easy, nothing fancy or anything. Now I have a local version running. Okay, so let's just connect it. Password. Okay, as you can see, I was able to connect to the local, and if you see list of tables and list of table spaces. So this is a tool called PGCL I'm using for Mac OS because I couldn't find PSQL for Mac OS. I'm sorry guys. This is pretty familiar. If you are familiar with PSQL, this should work fine for you. And this is I think a little bit I like it because it gives a really nice autocomplete, so you can just check it out. These are like your table spaces, and just by doing D plus you'll be like, okay, give me the database, but I don't have any database, so okay, we got it. Okay, go back to the code, and now what we are going to do is we are going to try to connect to that database. Okay, for before that we need to create a database. So what we are going to do is we are going to write query called create database. Okay, we already have one database called Postgres, but no, sorry, we already have a database called Tutes. So we are going to like describe. Okay, I did not connect through Postgres. Yes, I did connect through Postgres. Okay, I think we have a database called Tutes, so we are going to try to connect to the database. Okay, let's get started then. I'm kind of new with that PGCLI tool, so forgive me if I seem a little bit confused. Don't worry about that. Let's just try and just connect through the Go, right? Which is our main purpose, instead of going through all the tools and stuff. Yeah, one of the thing about Go, if you are not using the dependency that you imported, it'll go away, so be careful with that. Okay, now I'm just going to create db is equal to pg dot. So they have a method called pg.connect. Okay, so it is that easy. As you can see, all you have to do is pg.connect. It'll give, of course you'll be like, hey, where do I need to give host and user and port and everything. Okay, so for that we have something called options. So we'll create options, pointer to option is going to be like db.options. Okay, and inside that they have a user, which will be in here vj, that's me, and then I'm gonna have a password is going to put vj because it's a local and you guys cannot do anything about it. Another one is address, and our address is a column separated URL and port. So localhost 5432 sounds good. So these are like 3 fields which are mandatory. It should be okay. Yeah, okay, so it's showing that undefined db. Oh, sorry, it should be pg. Nice. Now what I'm going to do, I'm going to pass on this option here. Perfect. db declared and not used. Now what will happen, if it'll connect, it'll give us a pointer. So db is nothing, it's a pointer. Okay, so if you were to write something like this, you can write something like where db of type pg dot of type pointer pg dot db is equal to this. So you can say this is the type that we are talking about. Okay, db declared and not used, of course. So this is a pointer, right? So what will happen in the case of it will fail, it will throw an empty pointer, which is a nil pointer. So if db is equal to nil, means we'll just do log.printf. okay, it's gonna be something like fail to connect to database. That's it. And you can just do after that os dot exit with reason, I don't know, some number 100, like hey, I failed to connect. Okay, else, okay, else we don't need to write because it's gonna crash anyway. In case if it doesn't, printf, I'm gonna be like okay, connection to database successful. Sounds good. Now you have a db object. Whatever you want to do, you can do. And after doing that, what you have to do is close it. Okay, so once you are done with the db whole, because if you are creating an api, right, then it'll take long time, otherwise you can just close it out. So how you will close? So it'll be like close error is equal to db dot close. This should close it. Check for the close error. If his close error is not equal to nil, hence log.printf error while closing the connection. Can you print it out the error? How you do the %v? Right, reason. So these are like good way to write the logs. Okay, so when it will print, it will show you close error. You will figure it out what went wrong, and you can just do os.exit. You need to crash your program somehow after that, or you can just say log.printf connection closed and just return. That's it. As you can see, this is our basic. Let's compile and check it out. We'll go in here. Okay, go build it, compiled. As you can see, we have pgtut new binary. Let's run it out. pgtut. Okay, now what went wrong? Because we created the function but we never used it, right? So I'll just go to main.go. okay, this is gonna get tricky and I need to get that package. So I'll be like db. Okay, gonna prefix with db and hello world. After that I'll be like just call db dot. Let me check if that's the right define db dot. Yeah, why? Because small c, so it's a private function. Okay, and see the error is gone. Let's see. Sorry, go build, compile successful, clear it out, boom. As you can see, hello world, connection to database successful and connection closed successfully, which means yes, we were able to successfully connect to database, and connection after using, we actually close the connection. Now you will be like, okay, this seems really good, but how do I do queries and how do I insert data and do all those kind of things, right? Which you need to do when you are building really highly scalable server applications. So don't worry guys, in the next tutorial we are going to talk about, but before that, doing all the query and everything, you need to understand the model, how you will be able to convert the Go types into SQL types and all those SQL related PG types to Go type, right? Because serialization deserialization library already provides, you don't need to do that. So next tutorial we are going to create some structs, and we'll actually create a table according to those structs, and then we'll see how it works out and everything. Okay guys, see you in next tutorial. Hello guys, my name is Vijay, as you know, and In this tutorial we are going to talk about model definitions. Okay, so now what is model definition? So for example, if you're using some sort of language with some sort of database, right? So what you want is you want language specific data types to convert into Postgres or some other database specific data types, right? And you don't want to do that, so for that you have these libraries, so and one of the library that we are using right now is GoPG that we are discussing. And let's see how GoPG this converts all of your Go data types, I'm sorry, to Postgres data types. Okay, so when it comes to database, right, so database is like the root. Inside that you have tables, concept of tables. So those tables are equal to structs in Go or GoPG. Okay, so you can actually define all of your table as a struct and all of your field as a column of the table. It's that easy. Okay, so this is a simple concept of a product table that I just created in 5 minutes. So this is just to show you guys how it feels like. So this is a model of product that we are going to create. Okay, so let's create without wasting a lot of time. Say product.go. Okay, in the DB. How gonna be DB. Now to create a struct product. Type product. I was just checking if the autocomplete is working. Okay, so now this is equal to okay, so now when you're going to use PG, right, I'm just going to write down some comment how it's going to behave. So when you will actually run this GoPG migration or GoPG create table, right, that we'll be seeing in just maybe next tutorial, what it's going to do, it's going to create a table name products. Okay, so now the name of the table is going to be products. Why? Because one thing it'll do, it'll actually do all the camel see this kind of capitalized cases, right, it's going trying to make it in camel cases separated by underscores. So if you write something like product item, right, so it's going to create a table called product items. So what is happening is it's separating by underscore all the capitalized words that you're writing, and it's pluralizing it. Why? Because this struct represent one item, right, but table will have collection of items, so it tries to do that. So whenever you create table, just keep in mind that. But of course, if you don't want that and you want to manually write your name of the table, so there is a field called table name. Okay, this is a private field. So remember, all the exported fields or public fields, who's where the name of the field start with the capital letter, are gonna be actually working. All the private fields like this, they are just gonna get ignored, so you don't need to worry about that. Struct we can just product item collection. Okay, now what is happening is whenever GoPG will try to create the table, it will look for this field. If it field contains this, then now our table name is not gonna be like this. This is like the default way of doing, but we are overriding with product items collection. Okay, now let's create something called id integer. Okay, so this is whenever you are typing id or id, so it's going to track it. It's trying to make a primary key out of it. So this is going to be our id, and let me just check other fields. Name, unique. You can also change your column details also using SQL tag. SQL want to change the name of the id, it's going to be like id. Okay, and you can also give this is primary key manually. It's gonna get converted to primary key, but you can give manually like this. You can give primary key. Okay, another thing is this is a good practice in a way. I'm actually trying to make this thing unique, so you can see works, right? So this is how you give the constraints and everything. So just try to remember that you need to use SQL at column level. Okay, and it is good practice to just give your name here just to make sure. Okay, the details we have in description, price, description, path, feature. Now one another thing I would like to, what if you want to change the type? So you can just change the type by real, because if you do float 64 by default it'll try to do numeric or something like that, but I want real, small number, small floating point number, like that. So this is how you can change your Postgres type. Edit. Okay. Fine. So this is our whole data model got just created. So whenever we'll run the command called create table, right, it'll actually get all the properties and all the details, and it'll try to create a table out of it. Okay, so I think nothing is, what was this? Yeah, see, we just created a table. Okay, and I'm just going to close this. And it is a good practice, all the models you create in a separate go file. So as you can see, it's going to be like exported type and somewhere, I don't know. Okay, so as you can see, this is almost done. So this is how the modeling works. Okay, now you might want to know what type you are supporting, right? Also, here's the thing. So these are all the types that we are supporting when it comes to Go PG. Okay, so these are the Go types and these are the Postgres types. So if you see integer 8, you add, it's going to be small int, 16, 32 integer, and this and that. Float 32 is going to be real. Float 64 is going to be double precision that we actually talked about. Bool is going to be boolean, string is going to be text, byte is going to be byte array. If you are actually embedding another struct or map or array, it's going to be JSONB. Remember, this is really good. You want to try? Okay. We can actually try it out on features. Actually, we can just embed another okay, we can just give feature name. Name is gonna be feature description is gonna be, and I don't know, importance, how important the feature is gonna be. It's sort of like rating or priority. I'm gonna make it integer just to I know. So this should get converted to JSONB, or you can, what you can do is you give type JSONB. I mean, right? How hard it is, as you can see, it's really easy. See? Okay, so this is how you do. Even if you create a map, right, map will also convert into the, if you create array, it's gonna be JSONB. Nice. Time to time that we are doing is gonna be timestamp with time zone, and IP addresses we don't have. So I think that's it. Okay, what if you want to ignore some field? Okay, for example, I don't know, you want to use it, for example, for the struct purpose, but you don't want it in the table. So I don't know, let me just get a name. Okay, something like ref pointer. Okay, just ref pointer is just a reference number, you know, nothing else to do with the database. So what we can do is we can actually give like SQL underscore, so sorry, not underscore, gonna be SQL. Yes, so what this is going to do is this is going to ignore this field. Okay, so whenever the conversion is happening from go PG to PG or go to PG, you know, other side, this will get ignored, you know. So you can use it as a struct, normal struct data type in the whenever you're using the Go, but when you're using it for the reference of the database, this won't even create a column in the database, so it won't be present. So this is how you can ignore the field that you ignore. So I think this was it, you know, when it comes to modeling. So this is like the very basic modeling. If you actually want to get into the detail, right, you can actually go to the GoPG model definition Wikipedia, you know, and you can check it out, all the details. I think this is all they have, I guess. I mean, this is all it requires, you know. All the other things gonna be in the database specific, that you will have to write it in the database, you know. So okay, so the next tutorial, guys, we are going to see how to create a table using GoPG, you know, directly without writing any queries like create table this and these columns and everything else. Okay, see you then. Hello guys. So well, in last video we have seen that, okay, how to create model definitions and everything. Let's create a table out of this model definitions now, right? Okay, so I'm just going to write a function to create a table out of it. So I'm just going to be like function create prod items table. Okay, this is like my function, so don't worry. Might return error, nothing else. Okay, now it's very easy to write a create table. Okay, you need a little bit of options, so all the create table related options are stored. I'll just copy from product code. Okay, ORM is another sub module in PG which contains some options. So first of all, we will create options required to create a table. They are not required, but I think one of the options specifically you should write, just to be on the safe side. ORM dot create table options. One is if not exist, true. So this option will tell GoPG that only create table if it's not, if it doesn't exist, you know, just don't create it if it's already there, right? So what happens is this suppresses one kind of error. So for example, if you're running your script, right, and it's all automated, and you know, you don't check before creating and everything, so it'll throw an error while creating the table. So this is good. If it's already there, then we'll just ignore it. It won't create it, and it won't even throw an error. Okay, now just create error with okay, I also need a db, I guess, because reference db. Okay, so db of type pg.db, pg imported paste pg. How do we create? So we will have a database reference. Will just be like db dot create table. It's that easy. Give the model definition, which is reference to empty product item object and options that we had. Okay, code created. Okay, now let's check if create error is to nil, then just log it out. Printf error while creating table product items. Reason is create error, and we'll just do return create error, else code printf table product created. Well, our function is ready. Okay, okay, so when we connect to the DB, right, here will be just like error that I don't actually want to check. I'll just create products table with the DB reference that we had, and that's all before closing the connection. Okay, let's compile it. For that, because I already created that, so I just need to delete it, I guess. Just check it out if it's already there. Delete it first. Okay, so nothing is there now. Let's compile program. It's compiled. Okay, table product items created successfully. As you can see, let's just go here and check it out. Yes, we have product items collection. Let's, if you want to see in detail, you can just do there you go. So as you can see, this gives all the structure, right? So see, id is a big int, it's a next value, it's a serial, right, as we discussed by default. And primary key id already took it, right, and name is a text, description is text. This, see, feature is a JSONB, as you can see, right, and created this time zone with times boolean and everything, and this is the unique key that we created. So this is how it works. We just create a table out of coding without even writing a single query. This is really good. Got the options, right? If, for example, if you'll run it again, right, it's just saying table product item created. Why? Because it's ignoring the fact, but it's not actually creating again and again. If you see, right, it's just the same table. But if you'll remove this option, okay, this option, let's see how this pans out now. Well, error by creating table. Why? Because relation this already exists, as you can see, right? Now you don't want to check this again and again, you just want to ignore it. So you just put this. It's a healthy way of doing things, I guess. Okay, as you can see, it's working. So guys, this is how you create the table. Okay, next tutorial we are going to talk about how to insert some data in the table. Boom. Thank you, guys. Hey guys, let's talk about inserting some data now. Okay, so you have an object, you created an object, you have this API that get called, and you create this object, and you want to insert some data into, or you want to insert some product items in. Do that. Okay, so let's just, it's pretty easy actually. So let's create a function. It'll just receive product items receiver. I'm just going to call this save. It'll take db of pointer pg dot argument, it will just return. So inserting is pretty easy. Okay, so let's just see works. Well, it's gonna be like insert error db dot insert. I mean, it's that easy. I'll just pass on reference of my item, which is pi. That's it. And if I'll be like, if set error is not equal to nil, then error while putting new item to db. Oh, sorry, to print some reason. Percentage used for printing out the interfaces, by the way. Might be thinking. Done. Okay, otherwise, but product item. This is, we created a save function. It's going to insert it. Okay, now we need to call this function. So we're just gonna go to main. Okay, main will have db, so it's easy. Okay, should have gone to this. So I might make some changes. So when we connect, right, we should give a reference to db. We should be like pointer to pg.db, return this db. Okay, so we're gonna remove a couple of things like closing up the connection. We're gonna remove from here, put it. For now we won't even bother about that closing anymore. I'm just going to get the connection, try to create the table if it's not exist. Okay, okay, now there's a written db. So this is a video. Okay, now write your code here because this is integrated. Now you go to main.co. Okay, you create another say product. I'll take pg pg. I'll ask for db pointer here because I don't think we will need this. Yeah, pointer. Now what I'm doing is I'm just going to create a new product here. Okay, how do you do that? It's simple. New product item is equal to db dot product there. Let's just create this item. ID we don't need to give. We'll give something like name is gonna be yes. Okay guys, so let's create an object in here. Okay, 1 second. Okay, so I'm just going to give a name of the product one to copy all the name, description, product one, description. This is a test data. Oops. This is the main path. Right. $5. I mean, right? No big deal. This. Feature on description, and I had something else, I guess, something to do with importance. Right. Okay, it's a bummer. Yeah, so that's why you might want to, if you want to, if you don't want to add like a non-struct, create some other subtype or something. These are the techniques that you might want to learn. It's gonna be create. It is time dot now. It time dot now. Shoe boy. That's it. We created a whole product, as you can see. Let's save it now. So we already have a DB option. So what I'm going to do is I'm going to be like, okay, we give this a DB ref because we already have one DB given. Yeah. Now what we're going to do is okay, to DB ref. That's PGDB, and we have another. Okay, so what I'm going to do, I'm just going to do product item dot. We created save function instead, if you remember. But for that we need a pointer receiver, and it'll ask for DB ref. That's it, and it'll return to me. I'm just going to call this here product with PGDB. And as you can see, everything works. Let's compile and check it out. Well, it compiled. Wow. Product one inserted successfully. Let's see. Going to say select star from. What was the name of the table? I always forget. Product. I'm just going to copy this from. Well, as you can see, we have our first product. Okay, so name is product one, description is product one description, this is image path, price is 4.5. As you can see, feature is a JSON with values I added, right? I didn't do any encoding decoding, it's all done by the Go PG. It's amazing. Created at time, it took care of you, updated, took care, and exactly took care. This is how you insert. Okay, now what if you actually want like you want look to return that whole product, whenever you insert, right, you want that whole product as a written. So that also we can do. So I just go to here, is the insert save, right? So you can create some other function, something like phi. Sometimes you might want to have that whole struct written to you, updated or something like that. So we'll be save and return. Okay, so let's create a function called save and return. It'll again for db, it's gonna be digit. Instead of just return, it'll return a tuple with pointer to product, your product item, and error in case. Okay, so how do you do that? It's very simple. Okay, so first we need we already have a product that we want to insert here, but we need to create a new. Okay, so let's try it out. Insert error py dot del, sorry, it's gonna be like db dot del py dot returning. Okay, and you give me everything in return, then insert. Okay, so it'll give you result as well as errors. So it'll be result error. If insert error is, then log dot printf error thing dump. Well, I also might want to know what occurred. Mail, because you need to return to, right? Is log dot printf item lettered fully. I'll do another look. I just want to know what is actually we got, right? So received new value result is percentage, because we don't know the type. So that will print out, and then we'll return py. And let's see, I'm just returning py just for the sake of it, will here this is not the actual main, and we'll just update the product name to 2 because that's a unique field. Okay, everything just keep up. Everything else should be same, doesn't matter, but instead of save, I'll be save done. Should give new product item, sorry, updated product item, thing like this it should give. Okay, what if we just don't, because we don't need it, right? So just remove it, otherwise I might have to print it out here again. The same thing will happen. Let's compile, check it out. Yes. No error. Okay, inserted successful. New result is this. Okay, so we have a reference and we have this, so we need to actually get into the result and see what is actually written. Okay, so we'll go here, let's just say result dot we will get model, rows affected and rows written, right? So rows affected is we need to okay, let's check it out. So what was that in that? Here insert result dot model should give us, or a model dot, I think it's gonna throw an error because of primary, right? Yeah. Because so see, this is how you realize, that the thing is got inserted or something like that. Okay, it's a freaking pointer. But you got the idea, right? So you can actually get okay, let's see other thing. The rows affected. Yeah, because error. And this gets, yes, so that might also be integers. All the things that they're providing, right, they're pointers, so you might have to convert and do decasting and stuff like that. But you got the idea, right? This is how insert works. And okay, the other things, other kind of insert is bulk insert. Okay, that I thought I should talk about it. Bulk insert is it's like inserting multiple items. Okay, product item, save multiple. I'll ask for like items dot dot dot. If go, then this is called, okay, product items. References of product item. Error. Good. Let's see how multiple works. It's very easy. All you have to do is wait, set error db. Oh, we need db also, sorry. Like d gonna be like pointer to p dot d, and this should be pointer, not reference. Okay. How are you gonna do that? Okay, what is going on here? With final parameter. Okay, let's see. You cannot just use something like this in here. Put it here because it's periodic function parameters. Yeah, it won't be able to find it out then. Okay, looks good. Now I'm going to do db dot model. So model is actually when you want to insert, so I'll be like items. Okay, insert. That's it. Well, I think I'll give you some results that I told you, right? Number of rows affected and stuff like that. So we actually don't need that thing. Let's see. I'll score it. If set error is not equal to nil, printf error while inserting bulk item. Reason being, see what is the reason. Error. Set error or print bulk. As you can see, we did bulk. What we're gonna do, it's called create a couple of these items. The same function, I don't want to so much code. I'm just going to write two product. It's gonna be product number 5. Function name that we give it save. Well, first was DB reference, another was terms variable. Okay, and change to UPI. Got it. PI. Find. We have DB ref. We have ref. Yeah. Multiple. Okay. No, new PI one is function written the way it's written is a little bit wrong, but that's okay. Not error while inserting bulk items reasons model not pointer. Okay. I need to give pointers, and I'm giving the pointers. Okay, let's see what is going on. Pointer. As a pointers, I can do instead of this, and just variadic, right? So much for variadic functions. Then I'll have to create total terms to array the product. What do you think? Good to me? Total. What is going on in here? Okay. Even something like this. Yes, got it. Sorry for my misunderstanding with that thing. I think they're asking to give non-pointers. Okay, let's see. You go here. Okay, I think I got it, man. I think you need to give something like, you cannot just give array, you need to give something like 0 items. This is how it's supposed to be. Yes, see, this is supposed to be. You need to give variadic functions. You cannot give array, and I gave array. My bad. Let's just check it out if everything is there. Select star item. Hello guys. So let's talk about parameter placeholders. Okay, so you have written any kind of queries before, right? You might know that when you write the query, you actually, instead of embedding the value, you actually embed a placeholder like questions or dollar or something like that, and they just give the uh, query after that, right, that value after that, so that mostly in other drivers it helps again SQL injections and those kind of things. It also does in Go PG. So let's get started. Okay, so I'm just going to just give you a simple demo if you don't know already what it is. So I'm just going to create a small function, placeholder demo. Okay, we'll wait for, it'll expect .tv. Okay, now what we are going to, we will have some value that we would like to get scanned. Okay, so what essentially is happening, we'll do some query, and whatever that query will return, right, we'll actually put it inside this. Okay, so let's just run the query, db dot query. Okay, let's see the signature of this. So this query is actually a function that takes model, okay, and a particular query, and whatever input parameters that you're giving, and it will give you result and error. Result we don't care because it will give you number of affected, and this error, yes, select error. Okay, db.query. First one is the model. Model means what? Model means the data that you actually are expecting to put. So db.scan. Okay, sorry, not db, pg dot, still actually in so this is where you actually going to get your values. So for example, if your query is written in 5 columns, right, so actually you want to scan all of the 5 columns in here. So this is where it comes into the play. So that is first. Second one is query. So I'll just say query, and third one is params. Okay, params, I'll just put like some sort of value 42 for example. A query, I'll have to write query type string is equal to, sorry, select question mark. Now as you can see, as you can see, I've added question mark. So the question mark here is a placeholder, right? The placeholder is something that you put inside the query. Okay, and whenever you are actually running in some function, right, you expect that is to be replaced by some particular value. So in this case, what will happen is this query is actually this query, right? I'm just I added it as a variable. Now whenever this query will compile, right, so the GoPG will expect this GoPG will actually try to put this 42 in place of question. Okay, so what the query says is return whatever value that you are giving as input. Okay, so let's just see. Okay, first of all, if select error is not equal to nil, need to do error management. Error while running the query. I don't know, you tell me by printing. Okay, and then I'll just return select error, or I think everything's done. It should just say scan successful, all scan full scanned value. It's integer, so I can write percentage d and value, right? The query is successful, then we should get 42 as a result, and that's it, works. So I need to call this function like let's oops, sorry, db dot demo function name it. There you go, scan successful, scan value is 42. So you understood, right, how queries works in here, but this is not specific to query. Okay, this is just to know that what placeholders are. Now instead of this, for example, you can actually give positional placeholders. Okay, you can just give 0. So it will actually expect a 0th. For example, if you're giving here like 42, 32, 32, something like that. Oh, what happened? Vim crashed, I guess, somehow. Oh, that doesn't happen. Damn. Okay, in the setting. So now we have two values, right? What are you supposed to do? I'll just add 0. Let's see if it works or not. Okay, 42. And what if I'll just replace with 1? Damn, 41. See, as you can see, so these are called positional parameters. Okay, now what happens is, see, when we see currently the thing is it's very small, right, input and output. That's why you'll be able to do that. But trust me, I've written the queries where I was giving like 20 input as a placeholders, and what happens is I used to give like on the order. So now after that if you want to remove something, right, then you have to push everything one step ahead, and that it gets kind of messy. So instead of that, what you can do is actually like put on this positional parameter. So even if you like whatever that value that you need to change or something, right, it doesn't affect it. Why? Because it's not depend on the order, it depends on the position. You can actually give the position, it's that easy. Okay, one more better thing, the third thing that I would like to talk about is named parameters. Okay, so it's better than even positional parameters. It's called name. So okay, I'll just create a struct. Okay, type params struct param1 string param2 string. Okay, sounds good. Interesting. Now what I'm doing is instead of this, I'll be like param1. You see how it's happening, right? So this is like name parameters, but I need to create an object of that params. So I'll be like params, because I need to supply that, right? So it's gonna be like params param1 is gonna be like this is param2 is like this is param2. But when we return, we should be expecting, so now value will be string. Okay, now I'm written in this instead of all these things. I'll be just say params. See, this is pretty easy, right? So it should written what this is param1. Yes, let's see. As you can see, scan successful, scan values, this is param1. Well, I mistake in here, should have been percentage yes. Well, scan successful, scan value is this is param1. Okay, now if you think that I don't like this, we like param2, boom boom. Oh, where the crap that thing went. Sorry guys for the language. That's it. See, so it is that easy, right? You are not actually literally doing anything. See, so these are like 3 ways you can do placeholdering when you are using Go PG library. This I find it really interesting. So one of the thing I find it so interesting is the named parameters. All you have to do is just create some struct. For example, if you are writing some sort of big query, you just create a struct and put on all the conditions with key value, right? And remember one thing, you must I'll just finish that thing off. You can just put that, and you can just call it in here. I mean, it's that easy. So one of the other thing is, again, it's again parsing with the parsing all the capitalized into the camel case, separated by underscores and everything. So you have to be like that. You need to understand that thing also. So this was all about parameter holders, sorry placeholders, guys. Why I actually had to push this, because all the other queries, right, update or delete or select and all the other kind of queries, this is must required because you will have all the where conditions and everything, right? And all the conditions, mainly we use name parameters, so you have some better idea what name parameters are, right? So I just thought I should just give a tutorial on this before I move ahead with all the delete and delete and update and other kind of queries. So yeah, this was it. Try to learn a little bit about it. If you have any question, you can just shoot me a message. I would love to, or more than happy to reply you regarding this. Thank you very much, guys. Hey guys, well, in this video we are going to talk about how to delete. It's gonna be a pretty tiny video because there are just a couple of ways you can delete stuff, so no big deal. Okay, so I'm just going to, okay, now we have a product item and everything, but you might be thinking that I don't want this product item anymore, or you think that, oh, this is, I think, put by mistake or something like that, you want to delete it, right? It's pretty easy. Create a function product item and just create this delete item method. We'll expect pointer to dot e error occurs. Now delete is again pretty easy. Okay, what you do db dot, again first of all you select the model. Now model is what it'll actually put your whatever table item is, right, row into the, it'll load as a serialization thing, and then you can do whatever you do. So what we are going to do, so if you, for example, if you want simple delete, right, delete by primary key, which is like id, you can just do db dot delete, and you can just give pi. But in this case you might need this id, because what this does, it will create a query called delete from table name where id is equal to this. Okay, but mostly I don't think that will be the case. If that will be the case that you are deleting by id, then you can just do db.delete and be done with it. But yeah, of course, whenever you in this pi object, you need to have your id set. Okay, yes, but mostly that won't happen. Mostly you will be deleting based on some sort of conditions, right? So how do you do that? So simple, db dot, first of all you load the model, which is pi dot, you add the condition where let's say name is equal to placeholder name. Okay, and what should be the name? Come on, give me that, give me that, give me that. Okay, now that will get from here only, right? So we don't need to even give, and then delete. That's it. So I told you, right, last video tutorial, it's gonna be placeholders, name. So what is happening in here is when you do db.model, right? So now this model pi is in context. Okay, so whatever name placeholders are referring here, right, that we are referring from this pi parameter object, so that's why we don't need to separately here give any structure, because internally it'll take data from here, and then we just have to run delete query. Okay, it'll again return result and error. So it's result, we don't care. If there is some delete error, then we can just check it out. Okay, delete error is not equal to nil, then I'll be just like log dot printf. What I'm gonna do is I'm gonna be like error while deleting item. Reason could be percentage error to return delete error. Printf successful percentage pi dot got it. Okay, let's delete it. I'll go to main. We'll remove this placeholder demo. Okay, create a function delete item pg func delete item back db ref as pointer. So we need to create object, remember, because we are doing everything over that particular object. So the new pi is equal to p dot product item. I just need to give name because we are referring just name only, so name I'm gonna give what let's delete product 5. This is what matters, and I'm just going to run that thing with the db dot no sorry, you can run on new pi because we already have item. Sorry, I think it should be just delete with the ref. Okay, db product. Okay, let me just go to here and just say delete item. Yeah, so that was the name. Looks good. Out, build, delete successful for product 5. Now just text star from product items collection. Is auto complete. So if you see, right, product 1, product 2, product 3, product 4 and product 6. So product 5 is gone. So this is how delete works, I mean, there is no big deal about it, you can just write it down easily and it should work. Another thing is just an experimentation. Yeah, so you got it right. It's very easy. You just give the condition, and after that you just delete, you load your model in here, so this should work fine. So but usually if you see, right, people don't delete that much, they'll just set some flag is active to false or something like that. I mean, I don't know, they might want the data, but yeah, remember, this delete will literally wipe out your data. Okay, whatever data you're deleting, they're gone forever. So whenever you are using the delete, just be careful. Test it out on your staging or development environment before you actually put it in production. Otherwise you might mess up a lot of things that you might not get recovered unless you have backup or something. So this was delete, guys. Maybe next tutorial, let's just see how to do updates and stuff. Hey guys, look who's back. Yeah. Okay, and let's talk about updates. So last video I talked about delete. So I'm just showing you some of the promising way of doing things. Okay, there are, if you actually go to the documentation, right, there are like way different ways of doing things, but these are like the standard way of doing things, so you have to just keep in mind that. Okay, so let's just update something. Okay, so what I want to do, I want to actually update the price of this particular product with the product id product 1. Okay, so sorry, id 1. I'll just go to the database and I'll be like select star from product items collection. Okay, so I have like this many 1 2 3 4 sorry 1 2 4 6 and 7 ids, right? I just want, for example, this id 1, right? I just want to change I don't know, price to 5.0 in this. Okay, let's see how it works. So func product item. Okay, I'll just say update price function. I'll expect db as a star pg.db. okay, so now what I'm going to do is I'm going to write a query called db dot first of all, we'll load the particular model in the memory. So it's like, okay, loading, putting the context, and then what I'm going to do is I'm going to do like set. Okay, a set will take a string which, so what you want to set, so I want to set price. Okay, price is equal to placeholder price. So whatever price this pie has, right, we are going to set. Then you can write condition where, okay, and again placeholder id is equal to question id. So whatever id this has, it'll make it that, and then update. That easy, right? Whenever you do update, it'll send result and error. So result, again as usual, we don't care, update error. Okay, now what I'm going to do, I'm going to check update error not equal to, then printer error while string price reason. Let's see. Error all log.println price update dates 3, or I'll just give this like waiting. So let's see, pretty simple, right? No big deal. Let's go to main dot here, and we have so I'm just going to write another function here on the controller side, function update item price. Okay, I'll take db ref because we need to pass on dot db. So in usual conditions, for example, right, I'm actually taking just this, right? But what will happen when you have big project, right? You will have one context pointer, which will be a read-only pointer where all the database connections and all other configuration will be there. So you don't have to pass something like this. You just pass that and it should work. Okay, and I'll create a new pi, another object, kind of like this, product item. In this case we need id. Okay, so id, I'm just gonna be putting 1. We don't care about, we care about the new price, right? So whatever you are updating price, I'm just gonna be 5.0. These 2 fields require. Then I'll be like db dot pi dot update item price. Okay, or just update price. Let's see what it is. Just update price. Sometimes autocomplete doesn't work, I guess. Okay, it'll expecting db ref. Now for id1, price should be, when it runs, okay, delete success. Oops, sorry. Sorry for that. Red item price pg file price update successful id1. See, start from product term id. id is 1, price 5.0, as you can see. See, so this is how you do the updates. This is like the minor way of, this is like very standard way of doing update. It includes everything. It includes conditions, includes which columns you want to set and everything. So this is how it should be. Okay guys, so this was how you do update with GoPG. There are other ways of doing updates where you do update the whole structure based on just id, which is nothing. You just do db.update and put on that particular object and it will take care of it. But that is like, I don't think in real life that should be the case where you literally will be updating the whole item. You will be updating part of it, right? So this way, this is like, this works. You can actually set this and set another one, something like that. See that string and params, that, so work. So this was it guys from update side. Now the only major part remaining is querying. Now why I keep querying last, because it's kind of like a really not a big topic, but it's where actually a lot of confusion happens, right? Because if you see, right, insert, update, delete, they're like standard way of couple of ways of doing things with query, scanning and this and that requires a lot of stuff. So okay, we'll talk about it in future lectures, so don't worry. Thank you very much, guys. Hey guys. So let's talk about queries now. It's been a long waited, I guess you guys must have waited long enough now to learn about queries. Okay, let's not waste so much time and just talk about querying. Okay, let's just first write a simple function where we get the whole data of that particular product item by ID, right? Okay, to write the function item, get something like that. Okay, going to write a query about this. It's gonna be get is equal to dot, very simple. Why? So put everything into this and return. Select will return that if there is printf while thing do person. Okay, I'll just print the value in here, person whole I is a pointer. I'll just print it out. So the function is ready. It's pretty easy. Go here, here. Okay, then like get new, get d. I'll just take dbref. Sorry for those. It's my throat. It's not that much well today. Yeah, equal. Now remember this, because we just need ID, right? You don't need to create the whole struct. You can create something like this and to 1. So something right is equal to 1. So I'm going to pr dot id dbref. It should work. D with page. Good. Compile. Okay. Product 42. Oh yeah. Why there's a good price. Expected new. Oh, sorry. That was just totally out of context error, I guess. Well, as you can see in here, get by ID successful for particular thing, right? ID 1, product 1, product 1 description. the details. I got it right. So this is how you guys do get by ID. Okay, now you might be thinking, okay, this is all good, but you know, cup columns, few columns. Okay, and one other thing I would like to tell you is you can actually write this some well organized way. Also, this is like pretty basic. You could write something else like this. ID will give positional parameter in here. PID. You can write something like this also. Okay. Hmm. Yeah, okay. Dot. It should work. Let's check it out. Yes, it's giving me the same result. So this is like more standard way of doing things. As if you've seen all the kind of queries that I'm doing, right? What I do, I actually db.model. So what will happen is whatever the current struct, right, we are actually putting into the memory. So all the actions that we are doing, right, it will actually affect this pi model. Okay, so for example, if you're doing some sort of select statement, right, it will affect the pi. Sorry, it'll put all the values into this pi. Okay, so this whatever this inside this model, if you're doing updates, right, so it'll take all the updates from this pi and put it into database. If you're doing insert, right, then it'll take all the insert from this model pi and then put it into the database. And all the actions that you want to do, it should be at the last, right, and before that should be condition. So this is how the whole query that you can define. Now what if you just want like couple of columns? You don't want like all the columns. You just want like I think name and description you want, right? Well, you can do something like you can just create a column function. You just be like, give me just a name, description. I don't want anything. These are like the actual fields in the database. Okay, these are like the actual column names. So you have to give actual. So give me a name and description. So now whatever it'll return when you run it, right, it'll just return. Should return name and just okay. Okay, because other things are, if you see, zero, right, these are zero values, so it will still print the whole object, but all other values are zero values. For example, if you compare with this, right, the date is zero value, which is 000 and everything. So it, in a way, if you think, it just written product one description, everything else you see, this is image path and this, there is nothing like that. Why? Because it's a zero value. We are just printing the object, that's why. So this works. Okay, and now what if you want to do more condition? For example, id is this and name, thing like that. If you want to do let me just break it down into column. This where this whenever you can write multiple wheres. Okay, write multiple where, so this will work as a where this condition and, so this is like the and in this. Okay, where id is equal to 0 and name is 2 question 1. It should be also 0 because for this parameter it should be 0. Okay, the pi dot name, need to set name. This is like, give me all the sorry, give me just name and description of the data, where id is equal to this and name is equal to this. Okay, so you go here and put the name at this, will be name product one. So it h this right give you the results. Yeah, it is giving the results. So see, this works. So this is like and now you will be like, okay, what about or? Simple, you just give or where or. So this will work as a or condition where this should be or this should be. So instead of this, what we'll do, and be like id is equal to some static id 2. Okay, static id. So what this query will build up is, give me column and description from product item collection database, table, where id is equal to the specified id or id is to 2. Check it out. Sorry, to compile. Multiple rows in the result set. Yes, so what happens in here is it'll give you 2 rows, right? Because there is id1 and there is id2. So you'll be like, okay, so how do I deal with that? Simple. One thing you can do is actually okay, so let's just check it. I think you can, because this will result multiple, right? So you just say limit 1. This should do the trick. I can just limit, but I think this work. Yeah, as you can see, it'll give you product 2, right? Okay, now, but what if you want both, right? I mean, it's just not that you will want one. So what you do instead of that, you actually create another model where items is array of product item. Okay, now as I told you, right, you put this items in here. You got it, right? So now it will load multiple, so I'll just give 2. So by printing, I'll print let's see. Okay, we need to give the pointer. Yes, as you can see, now we have an array of items with product 1 and product 2. So this is how you actually select multiple queries. You can also do for example some sort of offset. For example, you just want to do one offset. So all the functions that you do in the query, right, you can literally do in here. They are all converted to functions. To offset this, just check it out. Yeah, so it'll just give you product 2. It's keeping the product 1 because of the offset. Okay, if you do offset 2, then it won't return any result. Yeah, and you'll be like, okay, I want to do order by, so you can do that 0, so it should return all. 2 order, I'll give you order by id. Yeah, so it should return in some particular order. Yeah, see, product 2 and product 1, right? If I'll make it id sending, it's gonna be product 1 and product 2. So you can even specify which order you want the items, and order, it can be ordered by time, it can be ordered by anything that is, okay, that can be ordered, something like that. This is how all the queries work. You can actually so these are like the simple queries. Okay, all the join queries and everything, there'll be another video that I'll be talking about, where you'll be seeing all the join queries and everything. But this is like the normal introduction, the simple components that you will be dealing with on a day-to-day basis, whenever because you will need like some specified column you want, that you can specify use column function if you want to give the conditions and all where and where, or if you want to specify some offset, that you limitations, you can make it order by and get select particular item, and you or anything else, you can just pass on that product item to another function, it will process and it will return to the whatever client, or client function or query function. This was like the introduction to querying and everything, guys. Okay, I'll see you in the next chapter. I'll be talking about a little bit in detail. Okay, bye bye. Hello, guys. So in this video we are going to talk about timeouts. You must be wondering what is that. I mean, you might never faced it, because it was all given to you. I mean, when when it comes to Go and PG and the driver, right, it is also given to you. It's just that I'm saying that how to customize it, so you can customize it when you connect to the database. Okay, remember the first video where we started connecting to the database? Yes. So in the connect method, right, I'm here in the connect method, we have a pg.options struct, right? Yes. So if you hover over that, you will see so many parameters, right? So we are going to talk about some of those parameters today, which are important. So first thing I'm going to talk about is dial timeout. Okay, so dial timeout is duration. So you can just set time dot time dot duration 1. You don't need to do that. Actually, you can easily do something like, let's just set dial timeout is 30 into time dot second. Okay, so what happens right now is, what is dial timeout? First of all, let me tell you. So whenever you are trying to connect to the Postgres database, right, it shouldn't be like trying to connect to the database infinitely, right? You want some time to time out. For example, if it doesn't connect in 30 seconds, you just want to return that particular function and throw some error, so you will get to know that what is happening. It's timing out, means there is something wrong from the PG side. So 30 seconds is again still a little bit high, but I'm just saying for the sake of giving an options or examples, right? So this is how you set dial timeout. Okay, see, there is no need to do tests and everything, because most probably you won't be getting it, because setting, I mean, making timeout is kind of like hard in the sense that practically it rarely occurs, but when it occurs, you are get screwed, I guess. I didn't know how to put it delicately. So the other kind of timeout that we are going to talk about is read timeout. So whenever you are running the read queries, right, all the select queries and everything, you might want to put 1 minute as a timeout, because you don't want your query to be running like infinitely, right? Because that's a lag, that's a connection is already occupied. You don't want to do that unless you are you get the cursor and you are like doing some infinite looping or something. But that is again a wrong way of doing programming. Your read timeout should never be 1 minute. It should be 30 seconds or 15 seconds. I'm just setting just to let you know, this is like the max timeout you should set. Another one is write timeout. Okay, so whenever you're writing the query, now why read timeout? Okay, write timeout, I'll tell you. Just for the example, I'm just going to put 1 minute. Okay, now why this read write timeout? Well, whenever you run a query, right, Postgres is actually doing a lot of processing, and for example, by mistake you run some sort of query without limitation. For example, if you're running a query where in the database you have, for example, 100,000 products, right, and you're running a query and you are just forgot to get the limit 10, and you are literally trying to fetch all the items. I mean, that's like a big deal. It might take a while, because transferring a lot of data here and there, at that time your query can time out, if it's 30 seconds. So you can actually visit the query and check out that particular mistake, and if possible you find and you can repair that mistake. So for that things you need to do that. And even if that is not the scenario, right, you really shouldn't run any query on your PG more than 30 seconds. That's a really added load over PG, Postgres itself. So other we are going to talk about is ideal timeout. Okay, I mean, this kind of thing, you don't set that much. You can put it like 30 minutes. Now what is ideal timeout is, The ideal timeout is, for example, if you are doing if you created a backend, right, and now your a driver is actually, have access to 100 connections. You created a pool of 100 connections, right, and all the connections are active. Now you don't get any query or any request from your client for 30 minutes. So you don't want to keep going with those connections, right? You actually want to minimize those connections. So this is called ideal timeout. This is really useful for controlling, how many sockets are getting connected, and when your sockets getting, closed down in terms of low load. So this is really good. If you want to set it out, don't set it 30 minutes, just set it like somewhat like 2 minutes, 5 minutes or something. Okay, other thing we are going to talk about is max edge. Okay, that's again time duration. Oh, sorry, time dot. So max edge is related to ideal timeout. It again say how the maximum age of your connection. So it's kind of like that before you do the ping. So what max edge will tell you that, if and anything, nothing happens for like 1 minute, just do the ping request to the Postgres, just to let Postgres know that we are still here, and we are active. So otherwise Postgres will think, if the connection is idle for long, right, then Postgres will think that, okay, there is nothing happening, I should close down this resource. So Postgres itself will close down the connection. So that not to happen, you need to have max edge. And another last setting I would say is a pool size 20. Okay, now what is pool size? Pool size is max number of connection per CPU, remember that. So by default the driver will try to balance it out, a number of connection per CPU, which is 10 by default. That should be more than enough. But if you think that you will be working on really highly concurrent environment, when you will be getting thousands of requests for doing the queries and everything, right, at that time you might want to set this pool size to little bit higher than 10. Okay, and remember this is like per CPU. So if you're dual core server, right, then it's going to be 20 connection, 10 to 10. So if you want to increase down to, I don't know, like 100, then you have to set pool size 50. So per CPU pool size is going to be like 50. So it should work like that. It does work like that. Sorry for that. So these are all the possible options that you should set in order to constrain your resources. Remember, for example, if you have really high-end Postgres server, like some big machine, then these numbers does not matter that much, because you already have a lot of resources. But I'm pretty sure in most of all the case scenarios, right, we won't have that much resources, unless you are in Facebook or maybe working in Google or something like that. So you will have like some small medium size Postgres, to handle very high amount of load. So at that time you might want to set all these options to make sure that everything stays, in a working condition. For example, if you even put some big query, or you might set a bug or something, right, everything should not fall down. So for that you need to set all these options, and keep track of all the options from the Postgres side to just make sure that everything is working fine. So this was all, guys, about how to set different kinds of timeout and pool size and everything. So this was it, I guess. Just remember, you need to do this. Okay, whenever you are doing, just please make sure you add dial timeout, read timeout, write timeout. Ideal timeout, that is okay, because systematically it will set as ideal, so we don't need to, because and it doesn't affect the performance. It is useful when you literally not getting any requests, so it's good. And max edge is again something like that. So these two can be optional, and pool size you need to set, guys, because otherwise your driver is going to keep opening the connections, or in the case of really high load, right, your driver will know what to do, and it'll just play around with the max connection, which is 10, and you will be a lot of requests will be getting stuck. Thank you very much, guys, for just going through this. Okay, I'll see you in the next tutorial. Hey guys, so in this video we are going to talk about transactions. You must be like, if you know Postgres and you work with Postgres and everything, then you'll be like, huh, interesting topic, but if it's first time for you, it's exciting topic, because I'm going to automate a lot of your manual work just by talking about transactions. You might be thinking, how? Well, let me tell you. So what are transactions, first of all? Okay, so transactions are nothing. Transactions are a block of queries, okay, that all either succeed or all fail. That's it. So it's just two scenarios, okay. So for example, you have a situation where you might want to three queries, and you want all the three queries to succeed, and in the you started writing queries and everything, right? And what happened, the third query fails. First two, for example, you have a three, you have some sort of a database management system where it's pretty critical, for example, the financial system you have, and you have sort of need to update three records. For example, you just update the purchase history in the user's profile, as well as purchase history in the actually product profile, and then you actually do the transaction, where which user purchased which item, right? And you were able to successfully update the purchase history of user and purchase history of product, but you were not able to somehow a query fails where you are actually trying to put on actual transaction where the user purchased this item and paid this much amount in advance. So what happens? Well, as you know, it goes down, right? So to avoid that, we have something called transactions. So what transactions does is, you have to actually create a block. Inside the transaction block, you write all the queries, okay. Now in case of third query will fail, right, you can literally just do rollback on transaction. So transaction will take care of all the updates that it did, right? It will actually go back to the previous version. So if it inserted some new rows, it will actually delete it automatically, so you don't need to worry about any of that. Literally, it's so good. Even if you for example, if you don't use transactions, right, then you might have to do everything manually, where if in case of any query fails, you have to actually go back and delete those records and stuff like that, right? I mean, come on, man, that's kind of like not so cool. So that's why the concept of transaction is here. Transaction is nothing, it's a block inside where you write all the query. When all the queries become successful, you do transaction.commit. In case of any error, you do transaction.rollback. That is it. Everything else is same. Okay, so let's not talk about theory more, and I'll just give you a small example so you guys have a little bit of idea. So how to create transaction in Go. Okay, transaction or transaction error is equal to, it's very simple, db.begin. When you do db.begin, it will actually open up the transactions. Okay, let me just check error very fast. Make sure you check all the errors, guys, because that's really important. Debugging is really important. Make right, because we were not open to able the transaction open the transactions, so that's why we are waiting, because we need transaction, and it'll be a rare scenario that you won't be able to open the transaction. Or remember, it's pretty simple. Whenever you write the query on DB, right, instead of write the query on transaction, that's it. Every query that works on DB will work on transaction. Why? Because it's like a block, right? But it's actually a part of DB only, so all the queries that I taught you in the last few videos, right, you can literally write all those queries on TX. Okay, now what you do, for example, see, I'm trying to update the price, right? And what if the error occurs in here? So what I'm going to do is transaction dot rollback. So I'm just going to say, if I made any change during these transactions, right, for example, sorry, if I made any change during this transaction, just please roll back everything, just remove everything, whatever updates that I did. Okay, but yes, if I am successful, then please commit the transaction. Remember, don't forget to commit the transaction, okay? Otherwise it won't affect and it'll keep the connection open and it'll cause a memory leak or connection leak. You don't want that. So remember, this is really useful feature, but you need to use it with responsibility, okay? So this is how transaction works. You open the transaction by db.begin and do everything on top of the transaction. You don't do db.query, no, you do tx.query on everything. So tx.model id, right? So currently what I'm doing is I'm actually updating one. So let's just try to, I'll just copy this, okay, and I'll just try to paste this, okay. Now what I'm trying to show you is two version of the particular thing, okay. Update error 2 2. Okay, so now what I'm going to do, I'm trying to update, maybe let me check what I should update. I should update with that, is active, okay. So I'm updating the price and then I'm updating is active. It should, remember one thing, you don't need two queries to do the updates, okay. For simple row, I'm just showing off as example. So just don't think that this is a wrong practice. I'm just showing off how transaction works. ID is equal to this ID, okay, you got it. Okay, then I'll do transaction rollback, otherwise I'll do commit. Okay, I'll go to main.go in here and I'll do is active false because it was true, right? Okay, let's compile it down. Okay, price updated successfully. Okay, is active is null, it's showing, okay, and price is 7, but it got updated, right? But we had a null value. Okay, let's check it out, what happened, what went wrong. We'll go to here and we have is active bool is active. Active it is PID. Might want to print that PID in here. I just need to make sure that if that thing is not gone, right? Sorry. I'm getting the fault. Okay. Oh, I got the idea, I guess. I think that was the wrong example to do, because what happens in here is uh, false is a false value, right? So that's why I guess. So if I do something like because if you see it's a zero value false is, okay, so this, and then I'll do, you have multiple options, pretty good. They should do it. Let's see. As you can see, it's false now, right? So both the queries ran. Let's try to update the price. to why it's not working. I'll tell you, because if you see is active, right? So for any boolean, false is a null value, sorry, zero value. So that's why this driver thinks that it is a null, so that for that you might have to use pointers and everything. Let me know if you get into trouble with those kind of things. I'll try to solve your issue at all. Would be happy to solve that issue. You know where to message me, right? If you see this video, just gotta message me. The price is 9 and this is again false. Okay, so both are updating, right? So transaction is successful. Let's see. Now I would like to fail the transaction. Yeah, so I'll just say something like said this, but this column doesn't exist at all, and I want to update the price to 10. Okay, see, I'm updating price to 10. Okay, I'll just remove this is not required. I'm updating the price to 10, but remember I'm actually trying to fail this query. So what will happen is it won't update even the price. It shouldn't. It better not. Okay, error while updating is active. So as you can see, price is 9, right? While price should update, if you see two queries, price should update and this should throw an error. This query throw an error, but we did rollback, so now price is 9. So guys, this is how transactions work. This is like a very, very naive example. Don't worry about it, but you got the idea, right? Inside of this transaction begin and commit, you write as many number of queries as you want, but you get into trouble. All you have to do is transaction.rollback and it'll take care of all the rollbacks for you at atomic level, so you don't need to worry about that. So guys, this was transactions. Okay, I'll see you in the next tutorial. Hey guys, so today we are going to talk about migration. Okay, how to because I got a question that I need to do some migration. Okay, all the projects and everything is set up, so how would I do migration? So I tried just looking through everything, best viable option and everything, and this is one of the library or CL application that I found, which is pretty easy. It's called Goose. You can just check it out, github.com/presley/goose. It is in my sense the easiest library you can find, and pretty productive library you can find when you need to do migrations. But make sure, just mind that this will be independent of whatever driver and whatever we are using. Okay, so this is Goose. What it can do, you can install easily with GoGet, nothing else, no extra dependency. And this is how you'll use it. It supports Postgres, MySQL, SQLite 3 and Redshift, all these database drivers. It supports with the Go, and commands are also straightforward. Instead of showing, let's just get started. What do you think? Yeah, okay. So here is a migration folder. Okay, I'm just going to go to CLI. Yes, and let's see. So go to migration folder, but remember that let's just do init. Okay, so how do you create a migration in Go? So for example, you have a basic setup. Okay, you created your database or you created your table and everything, and now you need a base migration. Sorry, even if you didn't create, you can actually create an init. For example, goose create init SQL. Okay, now if you see 0001 init SQL is created, right? If we go to 000 init SQL, as you can see in here, see all the files gonna be like this only. Okay, but versioning Goose will take care of it. But as we already have created init, right, we won't be going for the init, so I should be delete the 001. It doesn't matter, actually. Yeah, you can start from anywhere you are, and Goose will take care of it. So we'll do let's just say that we need to add one column. Okay, so in our products table, right? And we think that okay, what if I need to give some extra name to product, maybe secondary name. So let's see how we are going to do the migration, because we might want to store that information in DB, right? So what I'm going to do, goose product secondary name update, okay? And I want as SQL. Oops, sorry, need to create. Okay, now if you see I have this file. Okay, now I'm gonna go to migration. I'll create, as you can see the file is here, right? So what I'm going to do, and remember, you don't you cannot delete these comments. Okay, these are for goose specific commands, so you can delete this SQL, but goose up and goose down is actually up and downing of your migration. You cannot delete that. Okay, so just below the goose up, right, you can write whatever you want to add. Okay, so what we're gonna do, alter table product terms, that is our table name, product items collection, add column, what was that, secondary prod secondary name, good, null default empty. Sounds good. Let's see if it's error. Edit. I don't know why Veeam is showing that, but let's see. And now goes down is what you write. For example, what if you are not satisfied with this migration, how you will roll back your migration, right? That you write under goes down. So what is my logical solution? What I'm going to do, I'm just going to do alter table product terms collection pro column pro name. Okay, so it's easy. So when I for example, for this particular version of migration, right, I want to add one column in this table, but it doesn't go as expected. I want to roll back. Whenever I roll back, I actually want to drop this particular column, right? So this sounds like a viable thing. Okay, let's do this. So how do you run your migration? So goose, okay, already have that command because you need to run it in Postgres, right? So this is how you run your migration goose, and the driver that you want to use for database, and you provide your credentials, user, DB name, SSL override password, because that's required, because goose is going to connect to that. Then it's going to do all the migrations. Don't worry about the state. Goose will take care of the state over there in the DB only. Okay, we'll run up command. First of all, we run status command. Okay, so as you can see in here, right, we created this migration. We'll do up. Okay, I think we have something else already running, so I'll just going to do down. Oh, sorry, this is because I need to reset the goose, I guess. If you see, right, we have so we need to drop goose DB version table and goose migration. Drop table, because it will store your state over there, right? Okay, now let's see status. Okay. As you can see, this is how you can reset your goose. You can just delete the table and all the states will be gone. You can restart it if you mess up somewhere, just like I did. Okay. So when you do go status, right, it will show that how many migrations are pending and where we are and how many migrations are done, right? So this is our first migration, this is like the base migration. So let's do up. When you run up, okay, it'll actually, whatever migrations you have written, it'll actually try to implement all the migrations. So for me, it's just I have one, that's why if you do status again, it'll be like, see, this migration was applied at this date and this migrations, right? It'll give you really useful information. Okay, and you'll be like, okay, first of all, let's go and see if that column is there now. Item collection. Well, as you can see, it's there. Product secondary name text not null, default empty text, right? So as you can see, the migration was successful. Now I will be like, oh man, I don't want to do this migration, I just want to roll back. All you have to do is just goes down and it'll go down to one version. Okay, it won't go down to all the version, it'll go down to one version of my down. Okay, but as you know, we just had one version. As you can see, that column is gone now. See, so it's pretty easy with the goose, to just go up down up down up down. Now you'll be like, okay, let's do the status. If you do status, right, it'll again show pending. Why? Because we actually rolled down, so this migration is now pending. Okay, now if you want, you can do some changes and everything in the migration wherever you messed up, and you can just, I don't know, so update it and then again try to run it. If you have multiple migrations and stuff, well, you can just do something like up to. So for example, there is another command called up to. You can do up to whatever version you want. We'll do up to 1 because we just have 1, right? As you can see, we ran through that and goes now migration run. Current version is 1. So here is our version. Current version is 1 because we ran this one migration, right? So this is how the versioning works in Goose. Okay, you can just do, see, okay, so it's normal concept. For example, if you have 4 pending migrations, right? So up will try to resolve all the pending migrations. It will try to finish it off and will update the version accordingly. Okay, for every migration it's gonna be one version up. But when you do the goose down, right, it'll just try to go down one version, not all the version, right? But if you think that you want to go down like 3 version, you can just down to this version. Okay, our current version is 1. Okay, so I can just say down to version 0. As you can see, now it's no migration and current version is 0, which is our base version, right? So this is, you can this is how you work with this goose. Okay, see, it's simple. You just do goose create, SQL file will create. Okay, then you do all of your up and down queries that you want to write, whatever you updates you want to make, and in case of some error, whatever rollbacks you want to do, okay, you write it over there in the SQL file. Okay, and Goose will take care of everything else. You don't need to worry about versioning and everything. Okay, then after that, once you are satisfied with your SQL, you can just do Goose whatever database you're running and all the credentials and stuff, and you can just say up and it'll just go down up all the SQL files that you have written and it'll update the version accordingly. Now if you think that I don't need this, oh my god, I just made a mistake, and you want to go down, you don't need to panic or anything. All you can do is just say Goose Postgres credentials and down, boom, one version down. Whatever updates you made, roll back. That easy, so this is like, I mean, I went through 3-4 drivers, trust me, and I couldn't find anything as usable as Goose, so that's why I thought I should, guys, create a tutorial for you and tell you that migrations with Goose are really good and you should go with it. Don't complicate the migrations, trust me. Just because I've seen a couple of drivers where migrations are so much complex, you have to write a lot of code and everything. I was like, no man, that's not what it's supposed to be, so well, so this is Goose.